Okay, so do we have sound? Yep, we have sound. So I hope that we have gathered almost everybody that is willing to come. So welcome and thank you. It's glad for me. I'm glad to see you here. And basically, thank you for coming. My name is Alexander Kostadinov, and for more than 4 years now, I'm part of the team of Musawasov's team that is responsible for integrating new connected devices into the smart home platform of Deutsche Telekom. It's called Kivicon, and if you actually visited Simon Kaufmann's, so it's there actually session, he described the platform as a whole and actually gave pretty detailed insights over it. But now, basically, what I'm going to share today is I'll try to create a developer survival guide so that we share our knowledge how in the last year we managed to survive in the minefield of bugs and how we managed to fix the bugs related to smart devices integration. So basically, in details, what we're going to do, firstly, I'll try to clarify what our team is actually responsible for and what we do. Afterwards, I will clarify what obstacles we faced, what issues we had, and how our team actually managed to fit in the new situations, the hard times, and so on. And finally, of course, we will try to summarize and conclude all the lessons we learned and what was the morale for us as a team. But firstly, one question from me. How many of you attended the last year's ISTA conference? Pretty little. And how many actually attended the session that I and my friend Mitko Ivanov held? It was called Overcoming the Diversity of Smart Devices. Mitko, are you here? Okay, so probably some remember, but in any way, this was the so-called enthusiasm curve that we showed, and it demonstrated the way developers feel when they integrate devices. So if you see in the beginning of the integration, all of us are pretty excited. Then our first bugs and problems with the device communication and APIs and so on come, and here we get depressed a little bit. Then the device goes live for the customers, and of course we are happy, but then production bugs come and we are sad again. So what we're focusing today, after this flashback from the last year's ISTA, is the fact that we want to share some knowledge how we managed to get rid of these downs and actually make the chart be at least even and at the higher top. So what about our team? As I said, we are the team that is responsible for integrating the new devices into the smart home platform. So our aim, of course, is to integrate as many devices as possible so that the platform extends and fulfills the customer's needs. Of course, we also want to have no bugs, because bugs are bad especially for the security of the customer, but for the usability of the devices as well. And of course, these two combined, we want to have happy customers, and this is our ultimate goal. So what about our team then? What you're seeing now are the different roles that we have in the team. So this is the sub-team. I repeat, we're not the only team building the whole smart home platform. We are the sub-team for the smart devices. And of course, in the team, we've got developers, we've got QA engineers, we've got device managers, which are a pretty peculiar role, and of course, we've got a product owner. When you see product owner, please don't think that we use pure Scrum or Kanban. I can say we are just agile, but we are not following some strict agile methodology. So what does everybody do? A developer, of course, implements the pieces of code that, what we can say, translate one certain device's functionalities into a form that is suitable for our platform, and vice versa, translate the platform's commands and functions in a form that is suitable for the device. Then the QA engineers, of course, they manually test our pieces of code, our drivers for different smart devices, but they also write automatic tests so that some of the manual work goes away and they can concentrate of covering some functional edge cases which are pretty important when it comes to smart devices. Then we've got the device managers. This is the pretty interesting role because they are some kind of mentors between the customers, the business needs and management, and the developers and QA. So they have the knowledge what the customers need. So they define the requirements for the devices. So they define what functionalities of the device have to go into our platform and what not, and in what form. And they take care of the communication with the vendors. So we, as a developers, rely that the device managers have provided us with the API documentation for a given device so that we can start integrating it. And finally, of course, we've got a product owner because he has the crown. His role is to resolve conflicts, to set up priorities, and basically to act as a referee in the whole process so that all of us are happy. So, as I mentioned, probably, we're going to focus today on the progress we did in the last year. So, as a team setup, in the beginning, so the first 3 months, we were 2 developers, and we had 1 up to 4 QA engineers, so we always had at least 1. But at some certain times when more colleagues from other teams were free, they could jump in and test so that we provide more quality. We had 6 device managers, and this is important that a device manager is a manager for, let's call it, a bunch of vendors and not a bunch of devices, because, for example, for one vendor we may have 1 device integrated, but for other vendors which have common API, we can integrate 100 devices at once. So basically, one device manager is the leader of a group of vendors of devices for us. So we had 6 of them. Everybody responsible for around between 3 and 5 vendors. So you can imagine how big it was, the whole platform. And finally, we've got 1 product owner. Then the next 4 months, the change was that we became 3 developers, and we had a full 8-hour day working QAs on our side, 4 of them. So this was actually a pretty good change because this was the best time for the team in the last year. And then the final 5 months, so this is until October this year, we again were 3 developers, we had 3 QAs, so they were reduced by 1. Our device managers became 1 more, and of course the product owner was still 1. Now, I don't know, it can be seen, okay. So this actually describes the level of communication that we had. So basically everybody communicated with everybody on every topic, every time. Developers we wanted to know what device managers want, QAs wanted to know what they need to test, PO wanted to know everything. So it was actually a mesh of communication, which was pretty hard. So basically, do you know what this leads to? Consequent problems, of course. So firstly, the device managers always wanted and still want many devices to be integrated, many features to be in, and this has to be done for yesterday, so in negative time. In the meantime, devices are different to integrate. This is what me and Mitko explained last year. They have different APIs, and actually it is a challenge to integrate a new device every time. So it can't happen in a few days' time. Then here comes the PO, who tries to find the balance between the management requirements and the developer and QA needs. He tries to bring peace, but sometimes it doesn't happen. And finally, there is not enough time present because of the whole pressure to go to the market and, of course, to include more devices. So all in all of this leads to one big consequence, and this is having many bugs, of course. So this was the exact consequence that we had in the last year, and basically we had to deal with it. So back to our team, we all know that bugs, of course, are created for developers to fix them. But in the first place, developers were the people who implemented the code that caused the bugs, even if there is not their fault. So from now on, we're going to focus on what our team faced in the last year, but mainly from the perspective of the developer, so that's me, basically. And let's talk some numbers. And the next slide is the one I'm most proud of. So in the last 12 months, we managed to have opened and then fixed and resolved exactly 170 bugs. I'm not making this up, it's an exact number. I don't know how we managed to do it so round, but we managed. And basically, now we've got several pictures of how these bugs that we had were distributed. If we distribute bugs by type, you can see that we had 52 production bugs, but here the important thing is that we have several environments for work and testing, and besides production, we have the so-called pre-production environment, and here these 52% represent the bugs opened and found when testing on the pre-production and real production environment. Then 42% were development bugs, so these were bugs found firstly on the development environments and secondly during the development phase. And finally, we've got 6% which were pure user stories, and that's because usually QA came at our desk and we as developers said, oh, this is a minor fix, I want to open a user story and fix it now, please don't open a bug. So the bad thing here is that seemingly many issues had slipped through our fingers, at least to pre-production environment or the most worst to production. But then, if we measure these 170 bugs and split them by severity, you can see that 86% were of major, minor, and trivial stuff. So basically, what slipped through our fingers to production were some little and non-blocking issues, while the critical and the blockers were only respectively 8 and 6%. So yep, we had 52% bugs reaching production, but then we had 86% of them trivial and major stuff, which was easy to fix and basically was not blocking security or usage. And now, I know you probably won't be able to read all of this, but this is all of these 170 bugs split by category. And by category, we mean by cause, by what was the issue for them to happen. Now, some 1% share, probably the first 5, have 1% share of these 170 bugs. Basically, these are issues which were not really related to us. For example, there was a communication issue between us and the device managers. We just didn't understand each other, or the device's API changed without the vendor notifying us, or we had an improper configuration, whether it be hardware or software of our platform against the device. Then bigger percent, I'm showing there, I don't know why. Bigger percent, for example, we were not using external libraries properly, or we just had missed to provide some translations on our side, in our system, so that this caused QAs to open bugs for missing translations and showing unreasonable characters. Then 5% of these 170 bugs were opened because there were changes in our underlying framework which we didn't know or forgot or just neglected to check. So this was our own mistake. Then other 5% of the bugs were actually not reproducible, so we rejected them because we couldn't reproduce them. This could happen due to, for example, an overcramped network, and it may happen once, but it would never appear in some customer's home because the network is pretty not that much loaded. Then 22% of these bugs, the bigger, more important part, actually we rejected because they were opened by people from other teams or by our QAs, but in any way, these people didn't know the exact specification of the device. I mean, they were not acquainted with the functionalities that we had to implement, so they thought, this was not working, but then it was not expected to work. So 22% we rejected with this reason, and now the big lump, 46% of these 170 bugs, so around half of them, were caused by our own developer implementation mistake that we had done in our pieces of code, in our drivers for these smart devices. And believe me, this may include many things, such silly as I have committed my changes locally, some other has worked in my branch and has pushed it, and I just have forgotten to push my changes. I say, wow, this is fixed, but then it is not because the code hasn't gone anywhere, it's locally on my machine. Or we had missed handling exceptions, or we had missed, I don't know, probably we had missed to read the device documentation that for some reason had reverse engineered it, which is not good, and so on. So the reasons for this 46% were, in the most cases, pretty silly. And actually, with time, we figured out that we must be more careful, but we'll come to this later. So for every one of these 170 bugs, usually the first step before having the bug opened was that one of our QA colleagues came to our desks, the developer desks, and initiated a discussion so that they know if there is a real issue or not. And do you know how we reacted in the most times? Wow, go and restart your gateway or the device. And in the last months or weeks, actually, we were saying, do you know, NASA restarted Hubble, so why don't you restart your router or your device in order for this issue not to happen? Of course, we got the response that firstly, restarting is not a use case for the real customers, and secondly, what we found out with time was that a restart can only obscure and postpone the issue that will come back to you as a developer like a boomerang. So with time, actually, this is how things became moving, and we were moving very smoothly, actually. So in terms of time, what you see here is out of sequence. So here we're talking about combined work hours of many people and for one bug. So here at this point, we imagine that the QA in our team has set the environment for testing. Afterwards, he or she has started testing and has found an issue. Then a discussion is initiated with the developers. We have decided that there really is an issue. We have a ticket open and we investigate as developers and finally find the root cause. So all of these combined as work hours takes around 2.5. So all of these are my calculations. They are rough, of course, because sometimes all activities may take more time, sometimes less. It depends. But generally, that's my conclusion and my gut feeling. Then for us as developers to apply the fix, this means pure development and testing on our side, and sometimes regression testing of other functionalities to make sure everything is fine. This took around 3 hours. Then for the QAs to retest again, so setting up the environment again because they had previously switched to some other device testing. So switching back to the environment they were using and to the device they opened the bug with. Retesting takes around 2.5 hours. And finally, for us as developers to redeploy in the sequence of environments to go to prod, it took roughly 1 hour because of some CI jobs running, documentation writing, ticket creating, and so on. So that's how we basically split time when an issue was found. And I can state that one, let's call it major, critical issue could be roughly fixed within 8 work man-hours. So how to survive then in the minefield of bugs and how we managed to fit in the whole statistical picture you saw. So fixing these issues and making sure they don't reappear. Firstly, what I can say is that everybody should try to spot potential bugs. And what I mean is that everyone engaged in the team should use every opportunity to look for potential bugs, no matter what you're doing. For example, I'm a developer, I may be integrating a totally new device, and I may want to focus only on this. But in any way, if you click through some other device functionalities and you see something that is not in order, you have to retest, and you don't have to postpone a bug fix, because if you find an issue when doing something else, the least you can do is open a ticket for yourself, because otherwise other way you will forget about it, and with time someone will come up this bug and will open a ticket for you. But the bad thing is that until this moment comes, you will have forgotten everything you have done as progress to find it initially, and it will be double the work. So this is the first good advice. Use every opportunity to look for bugs, even if you're not using the devices at work, even if you're testing in your free time or whatever you do. Never be lazy to postpone a bug fix. Possibly try to fix it with some other job you're doing in the moment. This is the best case. And of course, check your own framework for changes in advance. I mentioned this some time ago, so if you remember, we had many bugs open because our own underlying framework, which Simon actually described, Eclipse Smart Home, which is open source, had some changes pushed to it, and they were often API breaking changes. But then we didn't have a specified schedule for checking for such. And what happened was that our regular changes become deployed at the same time as a newer updated version of the framework becomes deployed. And then after the deployment, we found out that some of our stuff doesn't work because of these API breaking changes. So what we learned here is that we had to regularly check and in advance. So potential bug spotting was actually a topic that that is to be done in the meantime, and that can prevent potential bugs to be present in your work. But then how to actually avoid bugs as developers, and why we are integrating the smart devices in the first place. Basically, the first thing that we learned is that as developers you have to try to make sure you handle all exceptions carefully, because in probably 80% of the cases you integrate a device which has a REST API or a cloud REST API or something like this. And it turns out that in some edge cases the devices return different responses, and some, for example, HTTP codes or responses that you never expected. Of course, what happens is that an exception is thrown and it is unhandled, and it breaks the whole flow of your code. So always try to handle all possible exceptions, especially the API ones, the ones that are thrown directly from the API. And of course, the first step to reach this is to read the device API's documentation properly, because usually at the end of it, of course, you've got a list of all possible responses together with the HTTP codes if we're talking about REST API. And we, of course, as developers, we are eager to implement the device. We go through the API endpoints, we implement them, we test, everything is fine. But then the device, for some reason, loses connectivity and goes offline. Or we get de-authenticated our user for the cloud service. In such case, we have 401 response from the REST API, and we haven't handled it because we have forgotten and we hadn't read this in the documentation. So that's point one. Always read the documentation the device managers have given you straight from the vendor. Then apply logging carefully, because it may save your life. You know that log files, so many of us relate to the log files as sources of trouble, as sources where we can only read bad news, errors, and stack traces, but it's not like this, because log files actually represent the whole chain of actions. So they should contain not only error messages and error event states, but they should contain also normal flow information, which could be useful for someone who is looking at the log files. So the normal flow of work of your integrated devices has to be logged there. but with care. So too much logging may take the reader's attention out from the main source of events which are going and can probably obscure some unwanted behavior from being seen and being prevented. And vice versa. Too little logging will actually give you log files that are nonsensical and that don't give you information which you can use. Then applied to this, many of us like to walk stack traces of exceptions. So what we do is try some code, catch an exception, so we fulfill our first rule. But then after we catch the exception, we directly walk an error and put the whole stack trace there. And probably it's not just me, it's many people here, when they try to find something in the log files, they want this to happen in less time, and they scroll fast and look for some indentation. So they look for stack traces. And do you know what happened? Our QAs did the same, and when they saw a stack trace, they said, wow, here's a bug, here's an error, I open a bug directly. Well, that was not the case, because sometimes actually, for example, if our OAuth2 token expires and we get a 401 unauthorized exception, we have caught it and we have reacted properly. But because we had walked the stack trace, QAs were saying, okay, it works, but I should not see this in the logs. This means there was an error. So then that's why this was our conclusion here. Apply logging carefully and print stack trace only if there is a real error, and a real error in the business logic. So if some of the functionalities are affected by this error, and not just because there was an exception of your code, because exceptions are to be handled. Then always check your concurrency logic during the time of development, because here it comes to smart devices, and for smart devices, many of the functionalities have to be controlled asynchronously. So, for example, some configuration of the device has to happen at some point, while in the meantime some other request is performed to the device to retrieve the initial data, for example, of some sensor and so on. So many asynchronous operations in terms of Java, for example, but in any way mean many threads and many threads trying to access probably the same resource, which may be some device configuration or some programmatical resource related to the device. And many times this may lead to either thread leaks, so you see normal behavior of the device, but then the device on which this code runs gets many threads running on it, and at some time you may run out of memory then. And there is no chance to see this until you see the device lagging and the device working slow, except, of course, you check explicitly. So because this is a pretty sneaky issue that is hard to find, it is good to think of it during the time of development. So if you have concurrency logic, think twice, because at some point this may cause you troubles that you may feel pretty hard to find actually. Then my beloved one, no matter of the code change, do full regression tests. So you may, in your piece of code that integrates a smart device, you may change that little thing. You may change a label, or that you display somewhere in the UI, or you may display the handling of an exception because you follow the first rule, or you may change the handling of exception, sorry. So usually, because for smart devices and for their APIs architecture, many of the functionalities are some kind of chain, so one depends on another, or execution of one command depends on the finish of another that was previously fired from or to the device, and so on. And in such case, a little change may fix a bug, but then it may open 10 more. So everyone has gone through this, and considering connected devices, this is a must. And always, when you do a change, you have to do full regression test. Because if you don't do it as developer, the QA will do it afterwards, and of course, the issue will arise. So you could have prevented this, and could have prevented wasting time of more than one people, more than you, by just clicking through all the functionalities you have implemented and you know, besides having changed 2 lines of code. Then, of course, in relation to this point, ask the QAs to test during the development phase. So you have done some changes to fix a bug, or you are implementing something new. Then if you know that one of your QA colleagues within the team has some free time, ask them to test, and ask them to test with your first initial stable draft of your changes, because even at this early phase, they can say, okay, but here I don't like this behavior, and you should ask the device manager if this is fine. So in any way, 2 more eyes, at least besides yours, are needed to check the code in advance, because this may save, again, the time of you and the QA that will then check once again. So initial check and initial lookup can save much time and many further issues. And then ask all team members to test during the development phase. In our case, what this meant was that I am a developer, I test. Then in the meantime, the QA tests and gives me ideas of what is wrong or what I have missed or what edge cases I have missed because I have implemented only the straight case. But we asked also our device managers because they could tell us if there are issues to the functionalities. Because if you remember the slide with the communication mesh, many times we didn't get, although we had it written, we didn't get what the device managers need and what they want to be implemented functional-wise for the device. And when they tested during the development phase, we could easily fix the functionality and the mechanisms we had implemented or change them accordingly so that they fit the customer needs that are defined for our task. So this is a pretty key feature, and sometimes even our product owner was playing because, of course, he had all the devices at home, so many times he was also testing and he was reporting issues to us. And now, if we imagine that we haven't managed to prevent issues to happen, and we have pushed code, and we have already bugs opened by our QAs. We have had a discussion, and it was decided that this was a real issue. How to investigate the bug quickly and how to find the root cause, because actually finding the root cause of a bug is probably 80% of the work, and 20% is fixing it. So firstly, we said it already, a restart never fixes an issue. So rejecting the bug and saying I restarted my device, my gateway, and everything worked fine, it just doesn't do the job. And it will postpone the issue because it will arise somewhere in the future for someone, and you have to fix it anyway. Have predefined setups for initial testing. What this means? This means that you have to ask your team members and your management to provide you with more physical devices that you can set up to work on the different environments and with different devices. The idea behind this is that you have predefined setups for testing every device on every environment and every change, of course, quickly enough so that you don't waste time setting up the environment. Because when it comes to smart devices, sometimes more time is taken for setting the environment than for testing the device and how it works and how it reacts and behaves. So having predefined setups for initial testing, will it be local, will it be on your machine or in your network and work environment, is pretty vital for quick reaction so that we reach these times of reaction that I showed earlier. Then make sure you retest with the same software versions. When you have a bug opened, always read carefully what was the version of the piece of software that was tested and on which environment, because it had happened that the QA has opened the bug for us and we tested with some newer code and were rejecting the bug saying this already works, but then the QA didn't know this because the version of the software was different. It may sound silly, but it happens, especially when it comes to some timestamp versions where the person who tests or the person who applies a fix has to look through a lot of numbers. So this is to be checked every time, no matter if it comes to the developer or the QA or whoever tests or wants to fix something. Never forget the log files. We already talked much about this. Log files are always useful. They have to have the necessary data for seeing the normal flow and fixing the abnormal flow. Usually an unhandled exception is the bug case, as I said, so roughly half. So half of the 170 bugs we fixed were our own mistake, and probably half of this, so a quarter of the whole, were caused by unhandled exceptions. So attention is the key here, attention to detail, attention to communication with the device, with the API. And finally, try everything you know before saying some issue is not reproducible, because of course we are humans, we are lazy by nature, so the best thing you can do is say, give this device a restart, and I have done everything and it's not reproducible. No, this was not the case, this is never the case, and if some abnormal behavior has happened, it will happen again. So be stubborn and don't surrender in the very beginning. So how we survived then? These were some good practices you can follow, and we followed stepwise in the process, but how we survived? Firstly, we kept constant communication between all team members, no matter of the rank, no matter of the work. So developer and QA communication is natural, it happens all the time, but we also kept constant communication with the device managers so that we know our changes or implementation are not harming the business logic. We also kept constant communication with the product owners so that we know we are working in the right priority. So we know we are fixing a bug that really matters, and not a bug that is of no real application for the customer. Of course, constant discussion initiation. None of us wanted to stay with his or her mouth shut. Every time there was an issue, everybody initiated a discussion. It may have been with the wrong person, but in many times it was with the right, and this pretty much helped us being proactive in trying to find a solution for a given bug. Of course, good knowledge. All of us had good knowledge of our system. Basically, this is to be gained through several years, and this is a point that comes naturally with time and work. But in any way, I have written it here because to gain good knowledge of your system, you have to be proactive in your day-to-day work all the time, so that you know at some point your gut feeling for finding a bug can lead you, and not just straight looking into the code. Of course, if you're a developer, you have to have willingness to fix bugs besides your regular development job. For example, I'm a person who likes implementing new devices. I like to see them work. I like to see them in action. I am not a real fan of bugs, but during this whole period, I said for myself, okay, I'll try to struggle, and I will take bug stories for me so that this doesn't break my normal development tasks, but I want to become better at finding the issues and the causes. And for me, this did the trick. So everybody has to be willing to fix bugs. All developers have to be willing to fix bugs, especially because probably their own actions were the root cause. And finally, I already said this, all team members took part in the testing. This was very good because otherwise we may have postponed some issues in time, so we may have actually prolonged their fix. So all of this combined means we were flexible, and how we reach this flexibility and agility. So every team member struggled to gain knowledge and experience in the project. So we were willing, as I said so far, and this gave us interchangeability. So I couldn't interchange a QA or a device manager, but at least if I'm off work and my developer colleagues are at work, we were interchangeable, and everybody knew at least a little bit of what the other was doing. Afterwards, our part of the platform was a bottleneck and still is, and we know this. So we always feel and take the responsibility to fix the issues that we created ourselves. And finally, every team member could help even if they were offline. This means that, of course, we had the desire to move the platform forward. And even if some of us was off on vacation on somewhere else, we were reacting to requests from our colleagues, and if we could be helpful remotely, we took the responsiveness and we were responsive so that we can move the issues forward. Basically, that's how I did it. Thank you. It's time for questions, probably. We have 4 minutes. Nobody?
Имате ли въпроси?
No? So, I know you're hungry, I'm starving as well. So, thank you very much for your attention.